in this section. If you flip back, that's when we are doing the over and under estimate for x squared. And we did it twice, once with 5 rectangles, once with 10. Let's just do it with 10 rectangles here. So when we did this, we had to add up all 10 pieces. And our area was length times width. So if I am looking at this for my function, is x squared, my number of rectangles is going to be 10. My interval, what was the interval on this one? 0 to 3. Alright, so we are trying to find the area under this curve. So we have the over and under estimate. Let's do the under first. So we had to add up length times width. We had 10 rectangles, so we'll have to add up from 1 to what? Okay. So if we go from 1 to 10, we have the length times the width. They all have a width of 3/10. And how did we get the y value, the height of these rectangles? Look back at your work. What was the first number we plugged in? So if we started with 1, yeah, with the underestimate we actually started with 0, didn't we? So let's adjust this. Let's start our I at 0, since we already know that when we did our underestimate we had started at that first point. And then so the first one was 0, the next one was 3/10, 6/10, 9/10, and so forth. So that's just 3/10 times your I. So when I is 0, that's 0. When I is 1, the next one's 3/10, 6/10, 9/10. And we had to plug that into the function, so we did 3/10 I squared. So if we simplify, 3 squared is 9, times 3 is 27. And we know that we can pull coefficients out in front, so if I just pull that out. 10 squared is 100, times 10, 1,000. I squared. And the I squared formula is n, which is 10, times n plus 1, which is 11, times 2n plus 1, 21, over 6. So let's see what we get when we do that. Actually have a problem here, because here's something that I failed to talk about. This is actually going to turn out to be our overestimate. Here's why. When you do the formula, what does it assume I starts with? 1. So we tried to fix it by making it start at 0, but if I do that, then I can't actually use the formula. So let's just pretend. Let's keep it how we originally had it, from 1 to 10, but this is going to be our overestimate. And I'll talk about how to get that underestimate here in a second. Sorry about that, I should have seen that problem coming. Okay. So this is our over. Now for our under, we already said we have to start it at 0. But we can't use the formula. So we have to think about when I add in that 0 part, let's just do that on our own. when I add in the 0, if I is 0, what does that whole thing turn out to be? 0. So does that term really change anything? No, but if I start at 0, where do I actually have to end? 9. So what we're going to do is add up from 1 to 9, because that first, my 10th rectangle was just when it was 0. And then it's the same thing. My length times my width. So 3 squared is 9, times 3 is 27, 10 squared times 10 is 1,000. Let me know if you have any questions. So now we do our formula. I squared is n, but my n is 9, times n plus 1 is 10, times 2n plus 1 would be 19 over 6. And we get 7.69. Are those the two answers we got when we added everything up by hand? Yeah. Now, for just 10 rectangles, this may not have saved us a ton of time because it does take a little while to figure out our formula and how to add things up. But if we were doing 30 or 40 rectangles, this would certainly be.
I'm not gonna be here last day, so once I get that work. Thank you.
There's going to be a video posted too. All right. So let's go to this. So we have been finding the area under the curve in all of these problems, but we know this is an estimate. We know the more rectangles we have, the better, but with just a fixed number, it's never going to be exact. So the best answer I could get, the true answer, would be if I set this up and did the limit as the number of rectangles goes to what? Infinity. The more rectangles, the better, so if I take it all the way to infinity, we would end up getting this. So the last problem on that homework, we were doing a limit as n goes to infinity. So that's the type of thing that we will see when we do the exact area under the curve. So let's do this same problem. We've done it twice already, but this time we're going to get the real answer. So we are going to have to do the limit as n goes to infinity. Now when we set this up, we still have the change in x. So that's your ending minus your beginning divided by the number of rectangles. But if I don't have a set number, that's just n. So my change in x is 3 over n. And then we need to find an x sub I. That basically means your x for the first rectangle, x for the second rectangle, x for the third rectangle. How are we going to find those x values? And so to get your x, you have to take your starting point, which is 0, and then each time we add the change in x, right? So for the first time I'd add 3 over n. Second time you add it, 3 over n again, and then again. So it's 3 over n times I for the first, second, third, fourth rectangle. So this is 3 over n I. So change in x, ending minus beginning divided by n. To get your x sub I, it's just wherever you start plus your change in x times I. So now we are going to set this up. We have the sum from 1 all the way up to n, because I don't have a set number of rectangles anymore. Length times width. Your width is just going to be your change in x. Your length is what you get when you plug that x sub I into your equation. So my change in x is 3 over n. If I take 3 over n I and plug it into my equation, I get 3 over n times I squared. if I simplify this, 3 times 3 squared is 27, and we know we can pull coefficients out in front. N times n squared is n cubed. So I have 27 over n cubed times the sum from 1 to n of I squared. So if we simplify that, we can do the formula for I squared. So n times n plus 1 times 2n plus 1 over 6. Right. So I can cancel an n. 27 over 6 would reduce to 9 over 2. What should we do here? Well, can I FOIL and distribute my 9 at the same time? So 2n squared times 9, so 18n squared plus 3n times 9 plus 9. And we could even split this up and do each one over the denominator. So 18n squared over 2n squared is 9. 27n over 2n squared would be 27 over 2n. And 9 over 2n squared. So basically, this is a formula. So if I said 5 rectangles, you can plug a 5 into this, and you get an answer. If I said 17 rectangles, you could plug 17 into this and get an answer. But what do I need to do if I want the exact answer? We need to do the limit as n approaches infinity of this. So what does that give me? We get 9 plus 27 over 2 times infinity is 0, plus 0, so we just get 9. So the exact area under this curve was 9. We did our over and under estimates. The best we got was somewhere between 7 and 10. So 9 certainly fits in that window. So this is the exact area. Questions there? Let's do another one. So, if I'm finding the exact area, you have to start with 2 pieces of information. Change in x and your x sub I. And we do these the same way every time. Change in x is your ending minus your beginning divided by n. So that would be a 4 over n. Your x sub I is your starting point, which is 1, plus the change in x times I. I want you to look at those right now and tell me if you have questions on how I got either of those things. So, then we will do the sum from what to what? One all the way to n, because we're adding up all n rectangles. Area of the rectangle is length times width. So the width is the change in x. And to get your height, you just have to plug your x sub I into your function. So my change in x is 4 over n times. I have to put this into my function. So this one's going to be a little ugly. This problem is significantly more difficult than any of the ones I'm giving you to do on your own tonight. So it's ugly because the function itself isn't real pretty and we started at 1 instead of 0, which makes it a lot harder. So we have to clean this up as much as we can. So in here we have 100 minus 3 times. To square this, you have to write it twice in the FOIL. So we would get 1 plus 8 over n I plus 16 over n squared I squared. So if I distribute my 3, I get a negative 3. So 100 minus 3 would be 97 minus 24 over n I minus 48 over n squared I squared. You guys still with me? So I distributed and combined like terms at once. Now, we can distribute this 4 over n. So 97 times 4. Over n minus 24 times 4, so 96 over n squared times I minus 48 times 4, so 192 over n cubed I squared. So now we're actually adding these up. Remember, I is the only thing that changes. So 388 over n is just like a constant. So if I add that up n times, what do you have to do? Multiply it by n. So this just becomes 388 over n times n. 96 over n squared times the formula for I is n times n plus 1 over 2. And the formula for I squared is n times n plus 1 times 2n plus 1 over 6. just done a lot of algebra to this point. But it's actually going to clean up fairly nice. And these ends cancel, so we just get 388. Cancel one of the ends. 96 over 2 will give me 48. I'll go ahead and just distribute that, so it'll be 48 n plus 48. Okay, 192 over 6 is 32. Cancel one of those ends. Can I FOIL this and distribute a 32 at once? Or am I gonna lose you? So 2n squared times 32 would be 64n squared plus 3n times 32 and 96n plus 32. We're almost there. I'm going to distribute my negative and simplify these fractions at the same time. So 48n over n would be 48 minus, this would still be 48 over n, minus 64n squared over n squared is 64, 96n over n squared, so 96 over n, minus 32 over n squared. And what do we have to do at this point? This is what it all adds up to for n rectangles. And how many rectangles do I want? Infinity. So now we do the limit as n goes to infinity. And anything with an n on the bottom just turns into 0. And so we get 276. So this says, suppose your odometer is broken and you need to estimate the distance that was traveled over a 30-second time interval. So what is done is they take the speed every 5 seconds and record them in the table. And I want to use these speeds to estimate the distance traveled. Okay. Distance is just rate times time, correct? And I gave you your velocity, I gave you the rate, and I gave you the time. But were you going at constant speed the whole time? No. So it's not like I can just say I was going 30 miles an hour for 30 seconds and multiply. That's not going to work. But what we can do is set up can I change this? Because I don't really want it to be this hard. Can we just pretend the units match since my time was, let's pretend our time was hours instead. Otherwise we're going to have to change those so the units match, and that's probably more complication than I want to add in here. Is that okay with everybody? So, rate times time. We can estimate this like we did with our over and under estimates. We can assume, so for every 5-second interval, we know the rate changed in there, but between 0 and 5 seconds, I could either assume that I traveled 17 miles per hour the whole time, because that's the speed I was going at the beginning of that, or I could take my speed at the 5 hours and say I was going 21 the whole time. Is either of those going to give me the exact answer? No, but I can do both and get an approximation. So it's kind of like doing the over and the under. Remember, with one of them we started on the right hand point every time with our rectangle, and the other we did the left. That's what we're going to do here. What is the width of each of these intervals? 5. So for every one, my speed is going to be 5 times, or your distance would be 5 times your speed. Can I just pull the 5 out in front? So let's just calculate both, and then I'll decide which one is my over and which one's my under. So let's say for the first one, we use the speed at the beginning of the time interval. So we know we would use these speeds right here. So I would test to add up 17 plus 21 plus 24 plus 29 plus 32 plus 31. So you're doing essentially 5 times each of those things, rate times time. And if I do that, what do we get? It's 50? Is that what you guys got? I got something different, so one of us plugged it in wrong. Could have been 770 is what I got. For the other one, what's going to change? We would assume, so basically this one, we were assuming the speed from the beginning of the time interval. The other option would be to assume the speed at the end of the time interval. So it's taking out that 17, and instead we would end at 20. And what'd you get that time? So the first was our underestimate, second would be our over. This is the distance we've traveled, so that's miles. So we know that we traveled somewhere between 770 and 825 miles. If I wanted to actually estimate a distance, if I wanted to give a single number for my answer, what would I probably do with those two things? Average, add them up and divide by 2, and that would be the best guess that I could get from this limited information.